Question number 21. Line L has equation 4y minus 6x equals 33. Line M goes through the point A 5, 6 and point P minus 4, K. L is perpendicular to M. Work out the value of K. So what I suggest you to do here first is to draw a small diagram to help you understand this better. There are two lines here, L and M, and the two lines are perpendicular to each other. So let's draw a small rough sketch. Two lines which are perpendicular to each other. So a small rough sketch to help us understand this better. So I'll draw the lines in two colors. So line L I will draw in green. Line M is going to be perpendicular. So maybe something like this. Okay, so this is, let's say this is our line L. So line L which has equation 4y minus 6x equals 33, and the other guy is our line M which has 2 points on it. One is the point A 5, 6, the other one point B. So it can be anywhere on this, so I'll just mark randomly over here. You can mark these points anywhere you want. Point B is minus 4, K. Okay, so line L is perpendicular to M, so it's perpendicular. Work out the value of K. So what we have to simply do here is we'll you can see since it's perpendicular, we need to simply apply the perpendicular gradient relationship. So if two lines are perpendicular, the gradient, let's say line L gradient is M1, the line M gradient is M2. So the two gradient, the gradient product will be equal to minus 1. So this is the relationship I'll be using at the end of the day to get the value of K. So let's take line L and let's calculate the gradient. So the equation for line L is 4y minus 6x equals 33. So what I need to do is I need to get M the subject. I need to find the gradient of line L. So what I'll do is I have to make it in the format y equals mx plus c. So in the format y equals mx plus c, where y is the subject, we can quite clearly see the gradient here. So 4y equals minus 6x, I'll be taking it to the other side as plus 6x. So 6x plus 33. Next I'll be removing the 4. The 4 goes to the side as a division. So taking it to both the individuals here at once. So 6x divided by 4 and 33 divided by 4. So y equals 3 over 2x plus 33 over 4. So we can see very clearly here in the format y equal mx plus c. So y equal here mx plus c. So the gradient is 3 over 2. So from here we can deduce the m1 value is 3 over 2. So now we're going for line capital M. In the line M, they have not given us the equation. They have given us two coordinates on this line. So what I'll do is I'll use the two coordinates to calculate the gradient M2. How do we get the gradient? y1 minus y2 over x1 minus x2. So y1, so let's say this is x1 y1, this is x2 y2. So y1 is 6 minus y2 is k, x1 is 5 minus x2 is minus 4. 6 minus k, 5 minus 4. Okay, now let's simplify. 6 minus k, 5 minus is going to be 5 plus 4, that's going to be 9. So M2 is going to be 6 minus k over 9. So now what I'm going to do is I'm going to use the gradient relationship that I said I'll be using earlier. So we'll use that now. M1 into M2 equals minus 1. Why? Because the lines are perpendicular. So M1 is 3 over 2 into M2 is 6 minus k over 9 equals minus 1. So numerator, I'll be multiplying with the numerator, denominator times denominator. So 2 times 9, that's 18 equal minus 1. So I can cut off the 3 and 18 here. 3 times 1, 3 times 6 is 18. So I have remaining here 6 minus k. We can't cut the 6 and 6 over here. So you must know that because there's a subtraction here. So here I was able to cut 3 and 18 because 3 is outside as a common factor. So taking the 6 to the other side, minus 1 into 6 is minus 6. So I'll be taking minus k here and plus 6 here, minus 6 here. So minus k comes to the other side as plus k. Here I have 6 and the minus 6 comes here as plus 6. So k equals to 12. So the value of k equals 12.